Welcome, everyone, to today's Explainer. You know, if you're a developer who's been tinkering with running local AI coding agents on your MacBook, you have almost certainly run into this incredibly specific, incredibly frustrating problem. You set an agent to work on some massive refactor or maybe a huge test suite, and you just want to go to sleep or pack up your machine for the day. But how do you keep it running without leaving your laptop wide open, just burning through your battery all night? Well, today we are looking at a really elegant open source solution to this exact headache, and it's called Adrafinil. Okay, let's dive into this. Look, there's this quote right from the project's GitHub repo that just perfectly captures the vibe here. It's 3 a.m., you're asleep. The agent isn't. It's still mid-thought in a session you started hours ago. Honestly, that is almost too relatable, right? You're completely exhausted, but to keep that AI agent alive, you had to leave your MacBook lid half open, propped up on your desk like an eyelid that just won't quite shut. It's a super clunky, improvised solution to a hardware reality. But until now, we really haven't had many better options. So why does this even happen? Well, it all comes down to what we call the clamshell sleep problem. It's just a fundamental macOS hardware limitation. By design, when you close your laptop lid, entering clamshell mode, the operating system immediately forces the machine into sleep mode to conserve power, which is normally great, but it instantly terminates or suspends your background processes, effectively killing your active AI agents right in their tracks. And that workaround of just leaving the lid open, yeah, that isn't great either. It often leads to severe thermal throttling, and by morning, you might wake up to a totally dead battery because the machine just sat there idling for hours after the agent actually finished its work. Now, you might be wondering, wait, don't we already have apps for this? And yeah, we do, but they're honestly pretty blunt instruments. Think about utilities like the command line tool Caffeinate or apps like amphetamine. They are essentially digital stimulants. They give your machine the caffeine jitters, keeping it wired and awake continuously, forever, regardless of whether any actual work is even being done. And developers constantly forget to turn them off, which brings us right back to dead batteries. Adrafinil takes a totally different approach. It's actually named after a real-world usoroig, which is a wakefulness-promoting agent. It acts in this targeted, event-driven way, doing absolutely nothing until an AI agent actually acquires it, and it only blocks sleep when that agent is actively computing. The mechanism Adrafinil uses to pull this off is remarkably precise. Basically, it's a macOS daemon that steps in using the command pmset disablesleep. See, regular public assertions don't actually beat clamshell sleep, so Adrafinil has to conditionally override it. But, and this is absolutely key here, it only overrides sleep exclusively while an AI coding agent has an active session. The literal second the agent finishes its task and releases the hold, Adrafinil gets completely out of the way. If there are 0 active sessions, your sleep behavior remains entirely untouched. So you can just close the lid and your Mac will sleep normally like nothing happened. And what really makes this tool a game changer is how accessible it is. Out of the box, it hooks into 9 popular AI agents and coding environments. We're talking Claude Code, Codex, and Cursor, Gemini CLI and Aider, alongside Hermes, OpenCode, Klein, and Pi. The developer actually put together this one-click installer that wires Adrafinil right into the hook systems of these agents. So for you, the sleep management is completely automatic. You never have to remember to toggle some switch on or off. The agents themselves just tell your MacBook when they need it to stay awake. Section 1. Technical Deep Dive, the architecture. Now, what's really interesting about this architecture is how it handles permissions, because overriding clamshell sleep requires elevated root access. Giving a third-party tool root access just to keep your screen off is definitely going to make security-conscious developers pause, right? That's exactly why the app is broken down into 4 distinct binaries across different privilege tiers. Up top in user space, you've got the menu bar app. That's just a pure view layer for status. Then you have the daemon, which holds all the complex logic, the policy, the telemetry. Crucially, both of those are unprivileged. They communicate down to the root helper via a secure XPC service bridge. And here's the really brilliant part. That highly privileged root helper is incredibly tiny. It exposes exactly one single function, set sleep blocked bool. That's it. All the complicated decision-making safely lives in the unprivileged daemon. So how exactly does that daemon decide when it's time to block sleep? It uses a super clean reference-counted assertion lifecycle. Let's just walk through it. Step 1, an agent starts a task, so the daemon bumps its counter up to 1. Step 2, since the count is now non-zero, the daemon fires off pmset disablesleep 1. Now, what if a second agent spins up? The count simply goes to 2. These overlapping sessions stack perfectly cleanly. Step 3, agents start wrapping up their work and the count starts dropping. Step 4, only when the absolute last session releases, bringing that count all the way back down to exactly 0, does the daemon reset sleep back to 0.
That guarantees you never end up with weird, nested sleep blocks when you're running parallel executions.
Of course, a natural concern when you're wiring a daemon into your coding workflow is performance overhead. Like, if every single prompt I submit to my AI has to talk to a sleep manager, is it going to slow me down? The short answer is no. Adrafinil operates on a super strict latency budget. The CLI is designed so those acquire and release calls round trip to the daemon in under 50 milliseconds. Because these calls sit right in the hot path of every agent session, the tool uses a thin socket protocol instead of full XPC for that initial hop. It ensures it will absolutely never bottleneck your flow. Section 2. Safety and thermal failsafes. So the crucial point here is that running heavy background daemons on expensive hardware, especially with the lid closed, is no joke. I mean, you definitely do not want your MacBook running a massive AI build while stuffed inside a backpack where it has zero airflow. Adrafinil tackles this head-on. The absolute most critical failsafe is the SMC thermal monitoring. The daemon continuously reads real-time data right from the system management controller, checking the internal temp sensors. If the SMC says, hey, the skin or CPU temperature is crossing a dangerous threshold and the lid is closed, the daemon immediately disregards all active assertions and force releases the sleep lock. It straight up prioritizes your hardware safety over completing the job, ensuring a bag-bound Mac literally cannot cook itself. But the protections go way beyond just thermals. There are all these rigorous process safety nets in place to prevent infinite loops or orphaned processes from silently draining your battery. First up, it uses KQ Note Exit for real-time monitoring. If an agent crashes out of nowhere, the daemon instantly catches it and drops the assertion. Second, it runs periodic sweeps looking for CPU idle processes just to catch delayed exits. And finally, it has this optional process sniffing feature. The daemon can actually auto-acquire a sleep lock if it sees a known agent binary running, even if you haven't explicitly installed the integration hooks yet. Also, I have to point out, the user experience touches here are really thoughtful. Because Adrafinil manages clamshell sleep, you obviously can't see a visual pop-up notification when you close the lid, right? The screen's off. Instead, they tied into the I/O registry to track the lid state. So if you close your laptop while an agent is actively holding an assertion, you'll hear this simple, satisfying little audio chime. It's just a quick ding, but it lets you confidently walk away knowing, yep, the sleep block worked. And then, when you reopen the lid later, the menu bar app gives you a nice little summary of what ran while you were gone, the peak temps it hit, and whether that thermal cutout ever had to step in. Section 3, Advanced Control, MCP and Installation. And this brilliantly illustrates how our relationship with our machines is shifting. We are moving away from manual toggles toward programmatic control. For the power users out there, Adrafinil actually includes an optional MCP, or Model Context Protocol extension. This literally gives the AI agent agency over the hardware's power state. Let's say you tell your agent to run a huge test suite or a complex deployment. The agent can calculate, okay, this is going to take about 30 minutes, and then it can communicate through the CLI socket at clip.sock to explicitly request a time-boxed hold. The AI is managing its own compute environment, setting explicit timeouts so the machine stays awake exactly as long as that batch job needs, and not a second longer. If you're thinking about installing this, just note that the system requirements are pretty modern. It's built for macOS Tahoe 26.4 or later, and if you're compiling from source, you'll need Xcode 26 with Swift 6 strict concurrency enabled. Also, because of that root helper we talked about, the standard install does require admin rights. But the whole project is completely open source under an MIT license. And if you ever want to remove it, the uninstallation script is designed to cleanly strip every single hook it added out of all your agent configurations. No messy leftover files anywhere. Which brings us to a really fascinating endpoint. Look, at its core, Adrafinil is an incredibly practical tool that solves a massive everyday headache for developers right now. But if you step back, it also hints at a much broader philosophical shift in computing. Think about it. If our physical hardware, the actual laptops sitting on our desks, now wake up, stay active, and go to sleep based purely on the independent, contextual needs of autonomous AI agents rather than our own keystrokes, well, who is really driving the workflow? It's a pretty provocative question about the future of automation and power management, and tools like this are really just the beginning. I highly encourage you to check out the GitHub repository and see this architecture for yourself. Thanks so much for hanging out with me for this explainer, and we will catch you in the next one.